Have you ever stopped to wonder why we only see one side of the moon? No matter where you stand on Earth or how you look at it, the same face, scarred with craters and majestic plains, is always gazing back at us. But why? This seemingly simple fact hides a phenomenon so incredible it feels like science fiction: tidal locking. And here's the kicker: it's not just the moon. This cosmic choreography happens all across the universe, so buckle up, because by the end of this video, you'll never look at planets or moons the same way again. All right, let's start with the basics. What exactly is tidal locking? Imagine two celestial bodies, let's say Earth and its moon. At some point in their shared history, the moon's rotation on its axis slowed until it perfectly matched the time it takes to orbit Earth. Essentially, one side of the moon is always stuck facing us, while the other, the mysterious far side, remains hidden, like a cosmic secret. But this isn't magic, it's physics. Here's how it works. The gravitational pull of a giant object, like Earth, tugs on a smaller object, like the moon. Over millions or even billions of years, this pull creates tidal bulges. Picture the moon stretching just a little, like a ball of putty because of Earth's gravitational tug. These bulges act as brakes, slowing the moon's rotation until it becomes tidally locked. And guess what? The same thing is slowly happening to Earth. Yep, the moon's gravity is decelerating the Earth's rotation by 1.4 milliseconds per century. But the moon is just the tip of the tidal locking iceberg. Did you know the same phenomenon exists for the closest planet to the sun? Mercury. For decades, scientists thought Mercury was tidally locked too, always showing one face to the sun. But here's where it gets wild. Mercury is in a special kind of cosmic rhythm called a 3-2 resonance. Instead of rotating once per orbit like our moon, Mercury spins exactly 3 times for every 2 orbits. It's basically like music, where the beats of rotation and orbit sync up in a beautiful dance. Let's hop out of our solar system for a moment and take a gander at exoplanets. Thousands of these distant worlds orbit other stars, and many of them exist in a region called the habitable zone, the not too hot, not too cold Goldilocks area where liquid water might exist. Here's the twist. A huge number of these Earth-like planets could be tidally locked to their stars. That means one scorching hot side is constantly baking in solar radiation, while the opposite side is plunged into eternal frozen darkness. But don't count them out for life just yet. Astronomers theorize that between these extremes, there could be a twilight zone, a narrow ring of perpetual dusk where temperatures are just right for life. Imagine living in that temperate zone, with one side of your planet eternally glowing with the light of a massive star, while the other is a pitch-dark abyss. That's the kind of alien world tidal locking can create. Here's an even crazier thought. Tidal locking can make planets literally fall apart. Take Kepler 78b, for example. This rocky exoplanet orbits its star so quickly, once every 8.5 hours, that it's being pulled apart bit by bit. Intense gravitational forces are distorting its shape, slowly turning it into cosmic debris. It's like watching a planet disintegrate in real time. Tidal locking isn't all serene dances. Sometimes it's a destructive force. And let's not forget the giants of our solar system, Jupiter's moons. Europa, Ganymede, and Callisto are all tidally locked to the gas giant. But if you look at Io, oh boy, things get spicy. This volcanic moon is locked in a gravitational tug-of-war with Jupiter and its neighboring moons. All that stress generates immense heat, fueling endless volcanic eruptions. It's tidal locking taken to the extreme. So where does that leave us? Tidal locking isn't just an astronomical oddity. It's a universe-shaping phenomenon. It dictates how moons orbit planets, how planets orbit stars, and even how worlds change over time. It creates extremes of heat and cold, pushes objects to their limits, and changes the very nature of time itself. Next time you look up at the moon, remember the invisible force that's been silently reshaping worlds for billions of years, all so that one side of it can forever watch over us. The cosmos truly never stops surprising us, does it? Now I have a question for you. Imagine Earth was tidally locked with the sun, one half scorched in everlasting daylight, the other frozen in eternal night. Where would you want to live? Let us know in the comments below. And don't forget to like, subscribe, and share this video with your fellow space enthusiasts. This outstanding video was crafted by VidWiz. Want your own exciting videos for fun or profit? Click the link in the description to get started today. Thank you for watching Science Spark, where curiosity lights up the universe.